Okay, so I've tried to get the focus right on this. So we saw 17, so we would expect 5 times 17 squared to be roughly equal to what? What was the other one?
38 squared.
38 squared. Sorry, I'm trying to type around the camera here. And we get 1445 and 1444.
Yep.
All right.
Oh, pretty close.
So that's pretty good. And what were the next numbers we saw?
It was 72 and 161.
72 and 161.
25,921.
Again, very close. And if we do n square root of 5, sorry, it's got to be a capital N for number. And then we do, what was it, 161?
Mm-hmm.
So I'll just make it a decimal, 161.0 divided by 72. We expect those two ought to be pretty close.
It's good to basically 3 places.
Square root of 5, 2.23607, 2.23611.
Yep.
So we're getting, you're exactly right, what he called near misses.
Yep.
But the neat thing is we're going to see these same numbers in the continued fraction for the square root of 5. So do you remember square root of 5? Do you remember continued fractions, I mean?
Mm-hmm.
Yep.
Square root of 5, we'll do say 8 terms of it. Okay?
Yep.
And I get 2, 4, 4, 4, 4, 4, 4, 4, 4, 4. So what does that mean? That the continued fraction for square root of 5 is 2, 4, 4, 4, 4, 4, essentially repeating forever.
So that's 2 plus 1 over 4 plus 1 over going down plus 1 over 4 plus 1 over 4 all the way down forever.
And then there's a neat function in Mathematica called from continued fraction, and it will tell you the fraction approximation. Sorry, it's hard. I'm having a hard time typing around the tripod here. So if I do from continued fraction of continued fraction, so this would tell me that 51,841 over 23,184 is the 8th approximation.
Yep.
But we weren't looking at that. We can just look at the first approximation, which was 2 or 2 over 1. Did we see that?
We did.
Yep.
The second approximation, what would you guess that's going to be?
9 over
9 fourths.
9/4. And remember, this would be 2 plus 1 over 4.
Mm-hmm.
Is that 9/4?
That is.
Yep.
Okay. And the next one we expect to see, the next approximation to the square root of 5 is
38 over 17. 38 over 17.
38 over 17. And can you see that 2 plus 1 over 4 plus 1 over 4 is 38 over 17? How do you work that out?
So 2 plus 1 over 4 plus 1 over 4. So that's 2 plus 1 over 5 fourths.
Okay.
So 2 plus 4 fifths. No, that doesn't make sense. I may need a whiteboard.
Okay, well that's fine. Maybe we'll go to the whiteboard and I'll just make it one continuous video. That's actually not too hard to do. And the next approximation is 161 over 72.
And what we saw.
So surprisingly, or I think actually pretty surprisingly, we're seeing the continued fraction approximations to the square root of 5 show up in the side lengths of these pentagons. Yep. Which is pretty crazy. All right, let's go real quick to the whiteboard and work out this prior one, that the third approximation should be 38 over 17, okay?